Do you know what's a P&ID and how to read it? So my name is João and today let's figure out. So what is a P&ID? So they are based on ISA 5.1. ISA is International Society of Automation. In industry, this stands as piping and instrumentation diagrams. These diagrams help us to understand how processes are being controlled and how they are handled, okay? Provide us a map for engineering system design, which is helpful to problem identification and problem solving. So this is why we use P&IDs to describe, to understand how a system works. For example, you have a water tank which is controlled by some valves, and those valves are shown on control panel on HMI. So we use the P&ID to draw, to imagine how they work. Core components of a P&ID. So these are the core components of a P&ID. So we have pipes. So pipes provide connectivity between different units in the control system. So pumps provide flow to the system. Valves, they control the flow, allows or block the movements. Instruments, so they are measuring device used to gauge level, flow, pressure, and temperature. So every P&ID has those pipes and lines. So dashed lines means electrical signals. If you have straight lines, it means there is a water or steam passing there. So every component has a unique symbol. As you can see here, this is a pump and this indicates the flow, as the pipes as well. So this is the symbol for valves. Okay, so it means a hand valve. And this is an instrument. Every instrument has a circle. And this is a temperature indicator. So okay, is number 01. So on the next page, we'll see how to name the tags. Each component has a unique symbol. Instruments use circles. Solid lines represents physical pipes. Dashed lines can represent electrical or control signal. Flow direction is mandatory. Pay attention to instrument tags because provide details on the measurement and control points in our system. If the physical instrument is visible and accessible to us, we use a solid line inside the circle, in this case here. If they are not accessible, we use dashed lines. See, the dashed line. Example is a temperature sensor inside a motor, invisible to operator. Imagine you have a motor, and inside this motor there is a temperature indicator. You cannot see. So how you show? You're gonna show it with a dashed line. So how to tag instruments? Okay, so first, identification. The first part identifies the type of instrument. The second letter describes the type of control device. In this case here we have TT. So this is a temperature and it transmits, so it's a temperature transmitter. In this case here, PT, pressure transmitter, so pressure transmitter. FT, so flow transmitter. And the last one is temperature indicator. E, so this control indicates, so it's a temperature indicator. And below there's a number, so to identify, so in this case is 01. So temperature transmitter 01. Let's practice, all right? Read a P&ID, it's like learn a new language. So you need to practice. So let's practice on this P&ID here. Okay, on the bottom, we have the information, the basic information. So this was drawn by me, the date, the system, in this case is the system of TA101, so it's a tank 101 and 102, and the title, process water tank control. Number of the page, we just have 1. So we must divide the P&ID to understand it. Okay, so basically we have one part, second, the third, okay, is the bottom. So let's start with the first. So these arrows indicates where it's coming from. In this case, the process water supply is coming from here. If you see in the other side, it's exiting the P&ID. It's going to customer process. And here, customer main drain. Just follow the arrows. The arrows indicates the flow. Here is going down. It's coming from the water supply inside the tank, passing here to another tank, going straight and then to the customer process. In this case, from the tank going to a drain. So now we have a basic overview. So what this means. So this is the symbol of a valve. In this case, a hand valve. If you look to ISA on the document, in that document show the symbols for each component, or in some case at the beginning on the first page of some P&IDs you have the tags. I'm gonna show you here. For example, for this system we have here some indications. HV, so HV is a manual valve. It means it's a hand valve. Okay, in this case it's hand valve 104. Hand valve 104 is a manual valve, half-inch manual valve. TA, if you go here, TA is a tank. TA1 is the main tank. So beside the valve, we have an indication. What this means? So this means is a half-inch pipe. Inside here, there's a process water. Okay, process water. 101, this is the number of the pipe. So let's talk about instruments. So if we have this tank, we have to measure the level, for example. In this case, we have a LSL 101. So what this means? Let's go to this page, and here we have low level switch. So this means this is a low level switch indicator, and this is a field mounted. So if you go physically to this tank, you will see this level indicator here, and these lines here, dashed lines, means is an electrical signal. So this electrical signal is going straight to the control panel. So let's recap. The process water come here. There's a hand valve. You can open it. Okay, open and close to control the flow. Goes straight to the tank. And there's a level indicator. And this level indicator signaling to control panel. We have here on the bottom of the tank, we have another hand valve 103. If you open this valve, the process goes straight to the drain. So now we are understanding the process. What's going on here? Beside tank 102, there's a hand valve 105 leading to pump 102. Let's have a look on here. So pump 102, water pump beside tank 02, controlling the flow. Okay, 700 liters by hour. So this is the capacity. So there's a pump here with a motor. Okay, this is a flow indicator. Remember, a circle. FI, so it's a flow indicator. So this is a field mounted. So if you go there physically, you see this flow indicator the flow meter basically, and beside it there is a hand valve 106 leading to tank 101. So the process water come here, pass this valve, so the pump, okay, controls the flow, passing to the flow indicator, which will measure this flow here. If it's open, will go through the tank 101. So what this means, what this part here means. So we can see the dashed lines. Okay, so there's an electrical signal happening here, going to LIC 101. Let's have a look. LIC 101, level indicator control panel located. So how do we know it's a control panel located? Because there is a straight line, circle, straight line. So this controls the flow, and above it there's another signal, okay, leading to LIC, so level indicator control 101. So this symbol here means is a HMI, is a showing on HMI. So if you go, for example, to control panel and if there is a HMI on it, you're gonna see the level status, because if you look on the tank 101, there's a level transmitter field mounted. So the level transmitter sends a signal to level indicator control 101. This is showing on the HMI, and here you can put the set points, for example, on this HMI, and this controls the flow. You can increase the pump by measuring by the flow meter, okay, seeing the level. Imagine you need to control the level here, and if it goes below 50% of the tank capacity, the pump will turn on. So if fuse is below 50%, the pump turn on. Okay, so this is a basic control. This is the ultrasonic level transmitter, the input for the controller here. This is another input, the flow indicator, and this is the output, the motor with the pump. So based on the set points, comparing the set points with the level, we'll turn on the pump or control the speed, the flow to this tank. Next to it, so this is a basic control. Next to it, there's another hand valve. This goes to the drain, and this follow to the next pump right here. Let's follow this. This connects with another pipe 102 to pipe 103. Both are processed water, half-inch, leads to a drain. We have the next pump. It's pump 101 with the motor, and here tells the capacity of this motor is a 12 volts DC, 1.4 amps, 14 watts. Under flow indicator 101, sending signals to flow indicator control. Here's inverter written here, but I messed this up. I will correct it later. Send it to the HMI, updating the driver status. Okay, so this controls the pump. And beside here, okay, XV101. We know this is a valve, but it's a different valve, you can see here. So let's check it out. XV101 is a solenoid valve. On the description below, there's a link to a Google Drive folder, and inside this folder there are some files. So I am giving to you this template here to edit. So because this is how we learn, we must practice. Okay, so I will edit with you later. So this is a solenoid valve controlled by the operator. So when this open, leading to customer process, this valve will open and this pump will act, okay, because we sense the flow here, flow passing. So when sensing the flow, the pump will turn on, taking the water, the processed water from here. Okay, so the levels will go down and turn this pump. Okay, so these the basic controls here, 1 and 2. All right, so this is a simple, and here I put just to illustrate the control panel. Okay, so this control panel will you have all the informations of this system. Electrical supply here, phase, neutral, and earth, 15 hertz the frequency. Okay, the HMI here is showing those indicators, okay, where you can put the set points. Another use of a P&ID is to maintenance. For example, imagine you're being asked to do a maintenance on this pump. So how can you isolate it? You can use the P&ID for this. So in this case, to isolate this pump, we must close the hinge valve 105 and hinge valve 106 here. Okay, so you isolate here and here, drain, isolate it. So now you can work on this pump, so nothing will goes from here and from here. Okay, if you must do some maintenance on this tank, you're gonna isolate here, open the drain and close here. So now it's isolated. Same thing here. If you must do something on these pumps and or this flow indicator, close here and this valve. Key takeaways: recognize standard symbols for instruments, valves, pumps, and pipes. Follow line types. Different lines indicate types of connections like process pipes, solid, or signal line, dashed. Tag identification. Each component has a unique tag, such as FT101 for a flow transmitter, which reveals its functions. As you can see here, we have all the information for that process, all the tags. Don't forget to check on your own P&ID. So this indicates what you have on it and helps you to understand more. Safety features: identify alarms, shutoffs, and emergency systems to understand safety measures. Well, in some P&IDs, you have low-level indicators, a high-level indicator for tanks, so alarms for temperature, so everything is contained on the P&ID. Okay, and the last thing is practice. Take a P&ID in your area, in your industrial area. So with a P&ID in hands, try to identify everything contained on that P&ID. Identify the valves, identify the controls, and what is showing on the HMI, what is going to the control panel. So practice. Open in the description below and there's a link for a Google Drive folder. On this Google Drive folder, you find the ISA standards and the template for the water type P&ID. Just open it. So you can edit. Actually, save it first, make a copy, and then you can edit. You can change. You can change here the indicators, the numbers. Okay. All the elements for you to practice and create one by yourself. Okay. Got any questions? Drop them in the comments below. Subscribe to the channel, like the video, and let's keep learning.